So role of cloud integration in IoT, right? So first and foremost use of that is data collection. Okay, IoT devices collect data from various sources like sensors, actuators and connected devices, right? So IoT devices like Raspberry Pi or Arduino, they get that data from the sensors. This data is typically transmitted to the cloud for further processing and analysis, right? Sometimes then and there the IoT devices can take decision for small applications, but if there is something required to some action has to be taken, in that case the data has to be transmitted into the cloud. Okay, cloud platforms provide the infrastructure to handle the high volume data generated by the IoT devices. Okay, so data collection, in terms of data collection we are taking help of the cloud, right? Cloud is playing a game even when it's talking about data collection. Okay, why I am talking about collection though we have something called storage? Because data is coming continuously, it is in synchronous mode, it is flowing like the water coming in the pipe. And how are we handling that data which is coming continuously? That is possible to be stored and updated in the cloud. Next, storage. Okay, data has been generating continuously, I want to store that data. Okay, right? Scalable and secure storage solutions for IoT is provided by the cloud. Okay, cloud can store vast amount of data, providing a centralized repository accessible from anywhere, like S3 bucket. Okay, wherever you are, you can, whatever data is being generated, that can be stored in the S3 bucket. Okay, because cloud is providing that much facilities and infrastructure to store that data. By leveraging this cloud storage, IoT devices can offload data storage requirements. IoT devices like Arduino, Raspberry Pi need not store much information. They can take advantage of the cloud by pushing the data into the cloud and getting it back whenever they want. Okay. Next, data processing and analytics, right? So yeah, cloud computing enables powerful data processing and analytics capabilities. We have Kinesis is there, one AWS Kinesis, right? We have IoT analytics. These are all the services in the AWS. Okay, we will see the practical. I will log in into AWS and show you all those features, right? So this processing and analytics, everything can be done in cloud very neatly, right? Complex data analytic algorithms can be executed in the cloud to derive meaningful insights from the collected data. Okay, some data is coming continuously, I want to derive some insight, I want to identify some pattern, that can be done in the cloud with the help of in the cloud I can execute those algorithms. That is possible for us, right? By processing IoT data in the cloud, organizations can identify the patterns, trends and anomalies. This is the most important thing, identifying patterns and trends. See, suppose I am talking about the moisture level in the soil in the farm, in the field, right? When there is moisture level, it may be giving 0 message to me. It means there is moisture in that. Continuously the 0 is coming. Continuously it is coming 0. Somewhere I get 1 or I am getting 1 continuously. It means there is a pattern here. The pattern has changed now. It means the soil has become dry, right? So this pattern I have to identify. So there should be some algorithm running on this continuous data. It should be monitoring that, right? That all processing, that programs which are used in identifying the patterns can be executed and written in the cloud. Real-time monitoring and control. Okay, cloud acts as a central hub, receiving data from multiple IoT devices, allowing users to remotely monitor and manage them. N number of people, lakhs of people. See, there are some IoT devices, maybe example could be CCTV cameras. You are having lot of CCTV cameras in a city, and everything, the whole recording of the CCTV is loaded into the cloud. And there are some police stations, PS1, PS2, PS3, like this. In a big city there are multiple PS. Each PS can log in, can watch their own area specific, monitor their own area specific videos, right? That is possible because the repository is single. This repository is single. S3 bucket could be, right? But everybody, individual users can remotely monitor wherever they are. They can play the data they can watch the data in the S3 bucket. Okay, right? So this enables remote configuration, firmware updates, and real-time control of IoT deployments. Okay, so next, ML and AI, obviously the ultimate solution. People are struggling today. No, they are talking about machine learning. They are talking about AI, running, executing the building models on the data, training the ML models on a specific data, and taking some decisions. Maybe classification, maybe prediction tasks they want to do. Right, that executing of ML model cannot happen in my local machine because of restrictions what I have. Blindly go for cloud. Cloud provides full computation power and the resources required for executing ML and AI algorithms. Right? Maybe I do not know. There are some faculty here. When you are teaching machine learning, when you are teaching the concepts of data science, AI, you are teaching with the help of local, in your local laptop, in your local systems. You are installing Anaconda, Jupyter Notebook. You are asking them to execute. But the same thing freely can be done in the cloud, because future we are not going to have any machines. Everything is going to be cloud. So training your ML model, pre-processing your understanding your machine learning data, can everything be done in the cloud. Okay, so when I want to implement some ML or AI algorithms on the IoT data, we have in required infrastructure, required facilities are readily available in the cloud. So only this cloud can benefit even in the IoT. Right? See, by integrating IoT with cloud-based AI services, okay, IoT data can be analyzed to develop intelligent models. So when you want to design an ML AI model on the IoT data, you can do it in the cloud itself. And the most important one, flexibility and the scalability, which we were talking about, right? It can handle dynamic load as and when the load is increasing. See, as the number of IoT devices are increasing, the data increases. When the data increases and there is huge demand of that, cloud platform can dynamically hold. Suppose, see, what is the maximum storage capacity of your laptop? Maybe 2 TB or maybe 4 TB. You want to store 100 TB, you can have a server with you. You want to store 1000 TB, still you can have a physical server. But beyond that, it is too costly. Go for cloud. Store as much as possible. Pay as you go. Pay as you use is the policy of cloud. Right? So for doing these important task, we need IoT in the cloud. Now the next one, connecting IoT devices to the cloud. How do you connect IoT devices to the cloud? So there are three best practices to connect different types of devices to the cloud. We will try to see the different ways of connecting the IoT devices to the cloud. IoT devices here means Raspberry Pi or Arduino or any other similar kits what we have, right? So the first one is directly integrate IoT SDK, okay, for resource rich devices, right? IoT SDK is available, download that and install it in that device, automatically connect that device to the cloud. That is one way, directly integrating. Second, rely on a communication module for resource constrained devices. For some medium level devices which are resources very less for them, then you need a communication module in between for communication between the IoT devices and the cloud. And the third one, using a cloud gateway for private protocol devices. Okay, we'll try to understand them instead of seeing them theoretically. Let's understand. So before we go, let's see this one diagram which clearly talks about lot of the architecture of that, right? So IoT device SDK is used to help us quickly connect hardware devices to the IoT platform. Okay, so you see here, hardware abstraction layer, then there is core layer, then there is interface layer and the sample code, right? So this code using API, using this MQTT or COAP, it is being so this is the different layers what we have in the IoT devices connection with the cloud. So we talked about OTA, we talked about COAP, MQTT, API, right? SLS, we have talked about these things, right? So the messages being transferred from one to the other using these protocols. So the first one, right, directly integrate IoT SDK. The first one or the most frequently used one is this only, right? Even if you want to connect some IoT device to your mobile phone, you have to use SDK. Okay, what is this? Right, try to understand how we can directly integrate. Okay, so there is an IoT device. Okay, the SDK is installed in that. It has some operating system, right? This using the MQTT protocol, you can connect to the IoT platform, directly connecting to them. So this can be any devices. It can be iOS, mobile, Windows, any device. You can have the IoT device connected to your laptop. You have a laptop with you. You have a Raspberry Pi kit with you. You can connect with this. Okay, using the help of SDK. Then this SDK can help you connect to the cloud. Okay, right? So this is one what we can do. With the development of high performance hardware, many smart devices have complete OS, like Linux, Android. They have this, and they also have the Wi-Fi or the network facility. Okay, so they can directly communicate with the IoT platform. This is one way of doing it, right? So what is the example of smart devices? Include smartphones, tablets, wearables, POS, computer, gateways, and development boards like Raspberry Pi. Okay, so using those you can directly connect. Next one, rely on some communication module. Okay, when there are some resource constrained devices, meaning I don't have high resource devices, little medium level facilities. If I have medium level configuration I have, then you can use some communication module, right? This MCU is microcontroller unit. Okay, microcontroller unit, and using the AT command, you can, there is a communication module. Through this you can communicate to the IoT platform. How does this works, right? In IoT scenario, a large number of devices are resource constrained. They are very small devices, right? They don't have much hardware, they don't have much storage capacity, even without an operating system also, right? So using MCU plus communication modules, we can establish a link to the cloud. With the help of MCU and the communication module, from that devices you can establish the connection. Okay, and the third one, cloud gateway. If you want to use some cloud gateway for private protocol devices, right? Same thing here. See, I have different devices with me. Using some network protocols, I am using some cloud gateway. This will get the data. From there I will be taking into the cloud. Okay, from devices using different types of protocols, I will get the data into the cloud gateway. From here I will be pushing the data into the cloud. Why? Because they don't have much network. See, for some devices they already have the ability to connect to the internet, but the protocols vary according to the device. That's why TCP or UDP or HTTP. Device has internet facility. Okay, we don't want the IoT platform layer to handle the parsing of these protocols directly. Therefore, we use an intermediate layer here. Satisfy the protocol conversion work to make the data meet the unified platform format. So from here we are sending it to the IoT platform, right? This intermediate layer is the cloud gateway, this one. Okay, this is at the front of the platform. It receives data from the device side, completes message parsing, and then sends the message to the IoT platform or the cloud. Okay, so these three are different ways we can connect to the cloud. Okay, so if we see, we have talked about what is the role of cloud integration in the IoT and what are the different ways of connecting IoT devices to the cloud.